Good evening, Harshit.
Good evening, sir.
Just wait for a few minutes. We'll start. Okay, good evening all. Is there anyone whose exams are about to start? Yeah, anyone whose exams are going on or they are about to start?
Good evening, sir.
Yeah, good evening. Anyone whose exams are going to start?
Sir, which exams?
Yes.
Sir, which exams?
Any school exam, right?
No, sir, I have in September.
Okay.
Sir,
Yes.
there is class test UT for me in UT for me. The cells, sir, lesson.
Okay, so classes you can do, I think, but just if you have any exams, like, so just inform if any special revision is required from any chapter, we'll be doing that.
Okay.
So in the last class, we were doing some revision from. So we were doing here a revision from motion. Today we'll be carrying on our revision from force and laws of motion. Just 1 minute. Sharing on. Someone had requested me to share the PDF in the group. So sorry, I couldn't share that. So, just after that, I had to format my laptop and everything went off. Okay. So I'll be sharing it today. I have got it again. So I'll be sharing it again. Right. So starting here from force and laws of motion. So let's try to fill out these quickly. All those who are responsive, so just be able to fill out these options. You can fill them quickly. So see, force, it is a dash or dash which changes or tends to change the state of rest or of motion, direction of motion, or the shape of an object. So what should be filled over here?
Sir,
These are the fundamentals. These are some of the basic questions. Yes, who can answer this question? Yeah, I'm not able to hear anyone. Is there anyone who is answering? Rohit?
Sir, direction of motion.
No, just see the blanks again clearly. I
It
hope
is
it's visible
dash
to you all.
or- Sir, direction of motion or the shape or size of an object, right?
See, it's the complete question here. It force is defined. So how is force defined? It is a dash or dash.
Push or a pull, sir. Sorry.
Yeah, it is a push or a pull. So we just say
Yeah.
a force is a push or a pull. Okay.
Sir, it is
If
a vector quantity, right?
okay, it is a vector quantity. The SI unit of force is
Newton, meter per
Newton.
second.
Newton. Okay, just Newton. And SI unit of force Newton, its definition. So what is 1 Newton? See, here you have the definition also of 1 Newton. 1 Newton is the amount of force which produces an acceleration of 1 meter per second square in a body of mass 1 kilogram. So it is that force which produces an acceleration of 1 meter per second square in a body of mass 1 kilogram. The other units like the CGS unit of force is dyne. So CGS means centimeter gram second. So you can perform the conversion and check. See, 1 Newton is also given as 1 kilogram meter per second square. And if I convert this to CGS unit, CGS means I'll be using centimeter, gram and second. Okay. So see, if I convert this kilogram to gram, I'll be having 1000 gram, and 1000 gram is 10 to the power 3 grams, right? 1 meter to centimeter, which is 10 to the power 2 centimeter. Then second will still remain the second as it is. So now I have 10 to the power 5 gram centimeter per second square. So this gram centimeter per second square is dyne. So I can say 1 Newton is 10 to the power 5 dyne. Got it? We have the definition of 1 Newton. So 1 Newton is 10 to the power 5 dyne. Okay. So here a relation is given in some opposite order, like it's given 1 dyne to be equal to 10 to the power minus 5 Newton. Okay. So shall we move to the next question now? Yes, all of you be alert and be active.
Yes, sir.
So I just want to put this and send it to you. See, I had to clear my everything. Just so just after the class, I'll be uploading it in the group only.
Yes, sir.
Okay. So I've got it here. It will be uploaded in the group. Now see question number 2. It's about the balanced forces. So when a number of forces act on a body,
Sir,
yes,
sir, is it option D?
okay. When a number of forces acting on a body do not cause any change in its state of motion or of rest or of direction in a straight line, then the forces are said to be balanced.
Sir, the forces are acting on the body is zero, right?
Yeah, the forces are zero.
Sir, it's option 4 is the only one which is right.
Okay, the resultant force acting on the body is zero. Right, so that is the only correct option. Your option 4 is the correct option. Very good. So only this option 4 is the correct one.
Sir,
Okay,
but
what will come
the
here?
question,
What will
sir,
be
is the
filled up in the blanks? What should I fill up in the blanks?
sir, is that state of motion,
In its state of rest
rest,
or of motion or direction in a straight line, then the forces are said to be balanced. See, the
sir, I
balanced
didn't
forces.
understand this question, sir. It does
Okay,
not.
see, the question is, you just have to fill in the blanks, and the other parts, they are the informations given to you. So this first part, they cannot set a stationary body in motion. Yes, this is also true. They cannot
Oh,
change the speed or velocity of a moving body. Yes,
true.
the speed or velocity of a moving body cannot be changed by the balanced forces. Also, they may change the shape and size of a soft object. Is it true?
Oh. So, sir, they only gave us the information about balanced forces.
Yeah, they gave the information about the balanced forces and you had to complete it.
Okay, sir, I got it.
So the third one, they may change the shape and size of a soft object. So we know
Yes, sir.
that balanced forces can change the shape and size of the object. Got it?
Got it, sir.
Okay. The next one is about the unbalanced forces. See, it again in the same way, you have to complete the blanks on your own. The remaining three, they are the information about these unbalanced forces.
Yes, sir, I got it.
So what do we get here? When the resultant of all the forces acting on a body
Not
Zero
equal to 0.
is non-zero.
is not zero. Ah, yes, sir, it's not zero.
When the resultant of forces acting on a body is
Not
non-zero,
zero, it's called
unbalanced forces.
unbalanced.
The forces are called unbalanced forces. So what can unbalanced forces do that are
So they
listed
can
here?
set a stationary body in motion.
Yeah. They can
They can
bring a
move an
moving,
object which is at rest to motion.
yeah, and they can change the direction of motion.
Yes, sir. So they can't change the shape of motion, right?
They can change the state of motion.
Okay, sir.
Okay, balanced forces can't change the state of motion. Unbalanced forces can change the state of motion. Now, the Newton's first law, also called as the
Law of inertia.
law of inertia. So, as a kind of revision, we have a statement also. It states that an object continues to remain in its position of rest or of uniform motion in a straight line unless an external unbalanced force act on it. Okay. So unless there is an external unbalanced force, uh, there will be no change in its state of motion. Okay. The next one, inertia.
Sir, it is a tendency of undisturbed objects to stay at rest or to keep moving with uniform velocity.
Yes, the tendency of an object to undisturbed objects to stay in the state of rest or to keep moving with uniform velocity. Very good. Okay, mass is the measure of inertia, or in other words, inertia is proportional.
Directly proportional to the mass.
Yeah, inertia is directly proportional to mass. Larger is the inertia, larger
More
is
is
the
the mass.
yes. Types of inertia.
Sir, inertia of rest, inertia of motion, and inertia of direction.
Okay, so see the first one. Inertia of rest.
Sir, it is a tendency of an object to oppose any change in its state of motion, right?
In its state of rest, since it is
Rest, sorry,
inertia
sir.
of
Yes.
rest, so it is the
State of
tendency
rest.
of yeah. Okay, I want everyone to answer. Pranav, Harshit, Likita, and Shravan. You're not answering.
Sir,
Likita,
sir, I had a
Likita.
doubt.
Yes,
Sir, what is force into time also known as the formula force into time?
that is called as impulse.
Impulse.
Yeah. Force multiplied by time, that is impulse. And it is equal to the change of momentum.
Sir, it is directly proportional to the initial momentum and final momentum, right?
Change of momentum.
Oh, yes, sir. Sorry.
Okay,
Change
impulse
of
is
momentum.
proportional to the change of momentum.
Okay,
Okay,
sir.
Harshit and Pranav.
Yes, sir.
Okay, so you people are not answering here. Okay. So try to answer the questions. Okay, so here two examples are given for inertia of rest. When a bus starts suddenly, passengers tend to fall backward, and
Yes,
when
sir.
a carpet is shaken, dust particles get separated from the carpet. So
Yes,
both of
sir.
them, they are the inertia of rest. So I think you can answer these very quickly. These are quite simple ones.
Sir, rest, motion, and direction.
Okay, explain giving scientific reason. When a bus starts suddenly, a standing passenger tends to fall backward.
Sir, this is because the upper part, the lower part of our body is at rest, while the upper part of our body is at motion. So when the bus suddenly starts, our lower part of the body doesn't want to change the state of motion it's in, so we end up falling down.
Okay, so in one word, you will be writing due to the inertia of rest.
Yes, yes, sir.
Okay, due to the inertia of rest, the
Sir, but don't
passengers
we have to
experience a
explain
backward
it?
jerk. Yeah,
Sir, in the exam, we have to give the reason why it's inertia of rest, right?
yeah, you have to write due to inertia of rest, passengers feel a backward jerk, or you can write due to inertia of rest, the passengers are uh, in the state of rest.
Sir, was my
And
explanation right?
yes,
Okay.
okay, then this one. Okay, see here, observe the figure and answer the following question. Which trolley is easier to move?
Sir, trolley A.
Trolley A.
Why?
Sir,
Sir,
because trolley B has more mass.
Trolley B has more mass, so
trolley A has low mass, so it will require less pressure,
Sir,
whereas
less
less
inertia.
force.
less
It
inertia.
requires
See,
less.
mass is directly proportional to inertia. So
Yes, sir.
trolley A has a lesser inertia and trolley B has a greater inertia. Now this question is about momentum. The dash possessed by a moving body is known as the momentum of a body.
Sir, the mass and velocity.
Okay, the mass times velocity, or the perfect thing over here is the amount of motion. So the amount of motion contained by an object is called momentum. The amount of motion contained of an object, the amount of motion content possessed by an object is called its momentum of the body. It is equal to the product of mass and velocity, and hence P equals to mv. Now what type of quantity is it?
Sir, scalar. No, no, vector, sir, because it has both magnitude and direction.
It is a vector quantity. The SI unit of momentum is
Kg meter per second.
kg meter per second. So it's kg meter per second. Okay, we'll do some numericals. Let's start with this. All of you will start answering. And now I think you can do these questions. So, what is the momentum of a body of mass 5 kilogram moving with a velocity of 0.2 meter per second?
Sir, 1 kg meter per second.
Okay, so this one. You have to tell the momentum of a body of mass 5. Harshit, what is your answer?
So 1 second.
Likita, present your answer also in the chat. Yeah, Rohit, present your answer in the chat. Okay, Pranav, did you get your answer?
No.
Okay, there is one answer from Rohit. Any Harshit? Pranav? Yeah, Pranav,
Yes.
Sharwan, what is your answer?
So
Sharwan?
1 kg, 5 into 0.21 kg.
Not okay. Its answer is correct, but write the units correctly. So answer for the first one is
Meter per
momentum will
second.
be given as mass into velocity. So this is 5 times of 0.2, which is 1 kilogram meter per second. Obtain the answer for second one also. A body of mass 25 kilogram has a momentum of 125 kilogram meter per second. Calculate the velocity of the body. Okay, again I'll be asking Pranav and Sharwan. Pranav? Pranav,
Yes, sir.
are you getting the answer?
Sir, can you explain first one again?
See, the formula of momentum, it is given by the formula m times v. Momentum is represented by the symbol p. So we have momentum p is equal to mv. Right? So mass is given here as 25 kilogram. Momentum is given as 125 kilogram meter per second. Then we
So the
need to
answer
find
is
the
5,
velocity.
right?
Yes?
The answer is 5.
Okay. The answer is 5. But what will be the units?
Meter per second.
Meter per second, right? So we get here momentum P as 125 equals to mass, which is 25 multiply velocity. So velocity we obtain as 125
5
divided
meter per
by
second, sir,
25.
is the
Yes?
answer. 5 meter per second.
Yeah, 5 meter per second as the velocity. For third one, find the acceleration produced by a force of 20 Newton.
Sir,
Now all of
force
you,
is MA.
yeah, force is equal to ma. Force is equal to ma. So see, Sampath, what is the answer? Sampath? Yeah, Sampath, what is the answer?
Sir, is it 4?
Yes, the answer is 4. So we use the formula F equals to ma, and from this we get acceleration to be equals to force by mass. So force is given as 20 divided by mass, which is 5, that is acceleration, and this is 4 meter per second square. So let's do some more questions here. So now we do question number 4, 5, 6. Find the magnitude of net force on a 20 kilogram mass if it accelerates uniformly from 2.5 meter per second to 5.8 meter per second. Okay, who got the answer? Harshit, what's your answer, Harshit?
Sir, just one.
Okay, Harshit.
We need to find the force. Sir, do we need to find the force?
Harshit, you are not audible. Just can you speak being more closer to the mic?
Sir, do we need to find the force?
Which one?
Sir, first we need to find the acceleration.
Mm-hmm.
5.8 minus 2.5 by 3.
Mm-hmm.
3.3
So here
by
acceleration is 5.8
minus 2.5 by
minus
3
2.5 divided by
upon 3.
3.
Sir, then we'll get 3.3 by 3. So when we multiply both with 10, we'll get 33 by 30, which would be 1.1 meter per
Meter
second.
per second.
Then, sir,
Yes.
you have to do force is mass into acceleration. So force is 20 into 1.1, which is 22 Newton.
So this is 22.0 or 22 Newton. Okay, so it seems okay, 22 Newtons. Hello. Hello. Become a class level. Okay, now the fifth one. Try for the fifth one. This was your answer for fourth. Try the fifth one now. Yes, so what is the answer for fifth one?
Sir, do we have to do 20 minus 0 by 0.25?
Find your answers, everyone. Harshit, Sampath. So I should not be calling your names every time. Just whatever answers you are getting, inform. Pranav, Pranav,
Yes, sir.
are you solving out the fifth one? Solve the fifth and tell the answer now.
Okay.
Yeah, okay, can you explain this fifth question? Pranav, can you try to explain the fifth one?
Sir, I haven't done it yet.
No, explain what all information is given in fifth question. Yeah, so what all information is given in fifth question?
Sir, mass is given. Mass is 200 grams.
Okay, so we are writing here mass m given as 200 grams. Okay, what else?
Velocity 20 meter per second.
Okay, which velocity is this? Read the question again and see. Is this average velocity? Is this instantaneous velocity? Is this initial velocity or is this final velocity? Which velocity is given?
Sir, acceleration is 40 meter per second.
You are getting 40 meter per second. Okay.
Yes. So force equals m into A. So it's 8 Newton.
Okay, what is A here?
A is acceleration.
Okay, how much acceleration we have obtained?
40.
40. Okay. So see here we have the initial velocity and final velocity given here. The initial velocity given is u, which is 20 meter per second.
So that's velocity, right? 20 is
Which velocity? See, it is saying a ball of mass 200 gram is moving with a velocity of 20 meter per second. So the
Sir,
ball is moving.
oh, sir, 1 second. Sir, I'm getting negative 16 Newton.
Okay, so just say we obtain. See, the initial velocity here is given as 20 meter per second, and it is stopped finally. So when it is stopped, its final velocity is given as v equals to 0.
Where is the force applied negative 2 Newton?
Okay, just I'm just getting the force here. So we have
Sir,
initial
we'll get negative 20.
time is 0.25.
Yes, sir. Sir, we'll get negative 20 by 0.25.
Yeah, negative 20 by 0.25. So your
So when we
acceleration,
multiply both with 100, we'll get negative 2000 by 25,
see,
which
your
becomes
mass
negative
mass is given as 200 gram.
so 0.2 kg.
Yeah. So it will be converted to kilogram, which will be 0.2 kilogram. So force is 0.2 kilogram.
Into negative 80, sir, because when we
Okay.
get
And then acceleration I obtain here as v minus u over
P
t.
by T.
So v is 0 minus 20 divided by time, 0.25. So this I get as negative 80 meter per second square.
So then we'll get 80 into negative 80 into point 2. No, negative 2 into 80, 0.2 into negative 80, which is negative 16
Yes.
Newton.
So yeah, final answer will be force equals to mass times acceleration, which will be 0.2 times of minus 80. So 0.2 times minus 80 is minus 16 Newton. Okay. All of you try the next question. Question number 6. Try
Yes, sir.
question number 6. A body A of mass 1 kilogram has acceleration 2 meter per second square. Another body B of mass 0.5 kilogram has
Sir, I got the
acceleration
answer.
on which body a greater force is being applied. Okay, just let me go. Rohit has given answer. Harshit has given answer. Okay.
So can you explain the answer?
See, the amount of force will be given by mass multiply acceleration. So force on A will be given as mass of A multiply acceleration. Okay. Mass of A is given as 1 multiply acceleration, which is 2. So you get 2 Newton of force on A. In the same way, we find out the force on B will be equal to mass of B, which is 0.5 multiplied by acceleration, which is 5. So 0.5 times 5, which is 2.5 Newton. So
Sir,
now which
body B
object has a
has
greater
more
force?
force on it.
Yeah.
Sir, body B has more force acting on it.
Yeah, object B has more force acting on it, and it is greater by 0.5 Newton. Now solve this C and D. So 7 and 8, not C and D. Okay, I'm making it. Okay. Now is it visible? I think it's visible now to everyone. question 7 and 8. Calculate the momentum of a ball of mass 450 gram moving with velocity of 120 kilometer per hour. Okay, it's again very simple. Just you need to convert the units. Just convert the units and you'll be able to obtain the answer for seventh question.
Your mass is 0.25 kg, right?
What happened?
So should we just multiply it or divide it?
See, when you are converting kilometer per hour to meter per second, you multiply it by 5 by 18. So for seventh question, mass is given as 450 gram. If you convert it to kilogram, so 450 divided by 1000 makes it 0.45 kilogram. So the mass is 0.45 kilogram.
Sir,
And
can I see the answer?
yes,
Sir, can I see the answer?
okay. So Harshit has sent answer. Very good.
Sir,
Okay,
is
let
it
me
14.985?
just checking it. So you have velocity given as 120. Convert it to meter per second. So 5 by 18.
Sir,
Mhm. Yes.
sir, in the eighth one, 10 kg should be converted into grams, right?
No, it has to be kilogram only.
Okay. Yes, sir.
Kilogram is the SI unit of mass. So it will be kept in kilogram only. So here I can cancel these two, or you can 6. Okay. So you get 100 by 3 meter per second. Now the momentum P is given by mv. So mass is 0.45 multiplied by velocity, which is 100 by 3. So you get 45 over 3, which is 15 newton, 15 kilogram meter per second. So I think Sampath's answer was correct. Sampath had sent the answer.
Sir, I couldn't
Harshit,
open the class,
Harshit.
so
Yeah, Sampath, what was your answer?
sir, I got 14.985.
14.985. So, okay, maybe, okay, that is also correct since you converted over there in 33.3, right?
Yes, sir.
Okay, so that is also correct.
Okay, sir.
Then, okay, try question number 8. Try question 8 now. और इसका connect हो जाता है, इनका नहीं connect होता है.
Sir, I got 27 kg meter per second.
Okay, what is the acceleration that we obtain here?
Sir, what is the time period for acceleration?
Okay, See, uh, first of all, we write down the quantities which are given here. So we are given here the quantity force. The force is given as, we are given force as 500 Newton. We are given here mass as, mass is equal to 10 kilogram. And can you find the acceleration now? Just with this information, force and mass are given to you. Okay, so I think Sampath has obtained the answer. He gave the answer as 4 seconds. Okay, let's check it out. So acceleration here will be equal to force by mass. So your force is 500 divided by mass, which is 10. So you get 50 meter per second square. This is the acceleration. Now, from the given conditions, your initial velocity and final velocity are given. So your initial velocity is your u
Sir,
initial. Yes.
sir, but they've also given us velocity, right?
So which velocities are given? The initial velocity and final velocity. And just they want us to find out the time that it will take.
Oh, okay, sir. I
Okay.
got how to solve the question.
So acceleration will be equal to v minus u over t. Since we know the
Sir,
acceleration,
it will be 1,000 seconds.
okay, let's check it out. So acceleration is, we have obtained as
Oh, 1
50.
second, sir. 40.
300 minus 100 divided by t. So your t is equal to 200 by 50.
40, sir.
40 or 4?
Sorry, sir. 4 meter per second.
Just
4
4
seconds, sir.
seconds.
4 seconds.
We wanted the time, and time is, we have obtained as 4 seconds. Right?
Yes, sir.
Okay. So see, every question here has some new concept. Okay, every question has some new variables, some new things. Okay, so we shall try a few more questions. Okay, for the Newton's third law of motion, as we know that action and reaction forces, let's quickly revise and then we'll move to questions from this also. So see, Newton's third law of motion, it states that to every action there is an equal and opposite reaction. Right? So when a player kicks a football, the football moves forward and the foot of the player moves backward. So that is action and reaction. Action, the force with which the football is kicked by the player, and effect of action force, that is the football moves forward. Okay. Action force is acting on the football, and if you talk of the reaction force, so reaction force exerted by the football on the foot of the player. Effect of the reaction force is that foot of the player move backward. Okay, now on this basis, we will try to explain the following with reasons. We are able to swim. Yeah, Pranav, why we are able to swim? Pranav, I want answers from Pranav now. Pranav, why we are able to swim? Yes, Pranav, why we are able to swim? Yeah. So have you got the answers? Hello, am I audible now?
Yes, sir.
Yes, sir.
Okay. So just I think in the mid there were some situations. There were some network issues because of which I was left. Just 1 minute. Just 1 minute. Let me reshare. I need to reshare the screen.
So the answer was third law
Okay.
of motion, right?
Okay. How the third law of motion is applied over there? How?
And
Yes. How the third law of motion is applied? Yes, anyone who can tell? Yes, Sampath is given the answer. We push water, we apply some force on it. As a result, the water too applies a force of reaction on it. So while swimming, we are pushing the water, and while pushing, we are applying a force of action. Okay. So water applies a force of reaction on it. Okay. Let's see the other questions also. Then second question. When an inflated balloon is untied, the balloon rises up. So why does the balloon rise up? Uh, yeah, Rohit, can you answer? When an inflated balloon is untied, the balloon rises up. Why?
Sir, because the gases are expelled out of the inflated balloon because of the third law of motion.
Yeah, explain it completely. You are right. Just explain it in complete.
Sir, because when we release the balloon,
Mhm.
the gases are exerted downwards, making the balloon rise up.
When the gases move out of the balloon, they cause a reaction force for the ball. They push when they move out of the balloon. Okay, so they are pushing the balloon in the upward direction. As a result, the balloon moves up and the gases move downward.
Yes, sir.
For third one, before a person jumps out of a boat in the shore, the boat is tied with a hook on the shore. Why? Yeah, Sampath. Sampath.
Where when we jump out of the boat, we apply a certain force on the boat, which makes it go further. That's why to prevent that, we are tying the boat with a hook on the floor.
Okay, very good. So then, fourth one, glass or bone china crockery is wrapped in newspaper or straw during transportation. So why we have glassware or bone china wares packed, bone china crockery, they are wrapped in newspapers or straw. Okay, think of this answer for the fourth one. Right? Think of this, what happens. Yeah, Sampath.
Sir, the glass or bone china crockery are usually very fragile. By wrapping it with newspaper or straw during
Okay, just
transportation,
see, let me explain this what happens here, and then you can put these in your own words.
sir, is
So
it
see what
related to the increasing of time?
this is related to the second law of motion.
Sir, so it increases the time of the rate of change of momentum, so less force is
Yes,
applied.
yes, very good, very good. It when we wrap it in newspaper, it increases the time. Okay, so hence it decreases the acceleration. Therefore, the force of one glass on the other decreases. When the force decreases, then of course you will have a lesser amount of force. Okay. The last question: fireman struggles to hold a hose pipe. Okay, see, when the fireman struggles to hold a hose pipe, so water from the hose pipe moves out. As a as a result, it pushes the hose pipe in the backward direction. So when the hose pipe is moved forward, it pushes the pipe in the backward direction. Therefore, the fireman finds it difficult to hold the hose pipe. Okay. Bye everyone. We'll see again in next class.
Thank you, sir. Bye.